All right, so Joe chickened out. He asked me before we started how to pronounce my last name, and he just introduced me as Todd. So Kjos is how we say it. Of course, that's not how they say it in Norway, and so I get razzed by my cousins because I don't know how to say my own name. So we're going to talk. It's hard to follow a talk that has lots of virtual reality and cool videos of visualization. So this is maybe going to feel a little bit like making sausage, but we're not actually talking about sausage. We're going to talk about the Android kernel, or kernels. And I'm going to start it off about a year ago, last November. My manager at the time, Ram Lemarchand, who was the manager of the Android kernel team, was brought to the Maintainer Summit. Linus asked him to come to talk about the Android problem. And it's actually a set of problems. And we're going to actually go through a few of those problems and how they're either still a problem or how we're addressing them. But fundamentally, from the maintainer's point of view, the Linux point of view, the big problem with Android kernels is that you can't run phones with Mainline because of a bunch of reasons that we're going to talk about. And so we're going to kind of go through some of the things. This is a LWN article. If you want to read it later, the URL is right there. So the first one, this is a quote from the article. The SoC market cycle is such that these chips will always run a 2-year-old kernel. Now, I think always is maybe too strong of a word, but certainly there are reasons. And if we look at what is actually out there running in the industry these days, you're going to see that they are quite old. Now, before we go into that, a few background items. First of all the Android kernels that are running are based on a long-term supported kernel from Linux Foundation. And most of them these days, the modern ones, are maintained by a guy named Greg Crow-Hartman, or Greg KH. And so the long-term supported kernels are based on Linus's tree. Linus declares a release. So say 4.19, you see up there, he's going to, when 4.19 is declared, that's going to become a long-term supported kernel, and that 4.19 is taken, and from then on, critical bug fixes and so on are brought in, and that's what support means, is that there'll be ongoing support for a 4.9 base plus bug fixes, security fixes, and so on that are needed to provide stability and security on that base. And so most products that are built on Linux are based on one of the long-term supported kernels. So I'm going to refer to these as LTS, long-term supported. So we're going to come back to that a little bit. And here is kind of a sad story of the phones that are deployed right now. So what this graph is showing is it's the Android releases, really. So you can go to the URL there, and what it's going to show you is, in this case, as of August 31st, this was the distribution of the various Android releases. And Nougat from several years ago, that's the biggest one these days, close to Marshmallow from the year before. So you can see it takes a long time for things to update. The new release Pi isn't on here at all. And this is one of the things we had last year. Ilian Malchev came and gave a talk about Treble. And Treble is about addressing what we see here, where it's so hard to update and the new releases take so long to get out there. And so my expectation is that Oreo is going to grow faster, or that Pi is going to grow faster than its predecessors did as more and more people are participating in Treble. But what we're still seeing is sort of the backlog of Marshmallow and Nougat, which didn't have all of the advantages of Treble for updating. But also notice the kernels that are running there. And this is actually kind of an optimistic view because the kernel numbers that I put there are the kernel version for the flagship that shipped for that release. So it was the most common introduced kernel. It doesn't include the updates. So if we really look at Oreo, we don't really have a way to track this right now, but if you looked closely at Oreo, it's probably mostly 4.4, but there's a bunch of 3.18 and 3.10 upgrades as well. So it really skews even older kernels out in the field than what you see here. And in general, devices are not updatable to newer kernel revisions, and that will probably remain the same. So we're going to look at one device in particular. This is the Nexus 5, and the way we used to manage kernels. When Nexus 5 shipped on KitKat, it was a 3.4.0 kernel, and if you look closely at that, you'll see that it's always been 3.4.0. It never updated at all. And so if you, in the right column, how old is that kernel? So the thing that the maintainers were griping about is that these are 2 years old. Well, the fact is it's even a little worse because it started off over just less than 2 years old, but rapidly just aged and aged until by the time we were done with Nexus 5, it was over 4 years old, even 5 years old, kernels running. Now, this doesn't mean that between those releases, the kernels didn't change. It wasn't the same binary image, because one thing that we at least were doing was security patches. And our security patch process, which is what you're looking at here, is the monthly Android security bulletin. And it's the security bulletin contains security issues for all parts of Android, but so what you see on the screen is some of the kernel things that called out for that one. And the way they populate this monthly security bulletin is that, well, there's a number of ways. One of them is just bugs found by developers at partner companies or in Google. Another way we find them is that we pay researchers. There's a bunch of researchers out there, and they get a bounty if they find a security issue in Android. And they can file that, and bugs are generated, and if our security team agrees and believes that it actually is a serious issue, then those researchers get paid. So we're paying for people to find stuff. And in this case, what's interesting here is this bulletin came out, and you can see it says that the fix already exists in the upstream kernel. And so one of the problems that we're having, and we're still having, and that we're working very hard, is that a lot of the security bugs are not marked as security bugs in LTS kernels. Greg Cage, says, look, we get these bugs in. We don't know that they're ultimately going to be security problems. We just know that lots of major things are being fixed in the LTSs, and downstream on devices, people aren't taking them. And so devices become vulnerable. And even now, when we have a security release, the security releases only contain the patches that are cited in the security bulletin. So if somebody actually found it, then it might be fixed in security bulletin. But sadly, a lot of times, the way we learn about a security problem is like this, where some nasty problem is found and it's in the press, an exploit. And so this is an exploit this is an issue that happened on Nexus 5, 3.4.0 through its whole lifetime. But there were a number of times where problems that manifest in the field would have been fixed if only we'd been taking the LTS kernel, merging it down, and patching the device regularly with it. But we weren't doing that. So a couple years ago, as part of Treble, we revamped how we do Android kernels. And so we're going to describe it on this slide. So the blue you see is the LTS kernel. So that's maintained by Greg KH for most of the ones we are maintaining today. The yellow is the Android common kernel. That's what my team maintains. And so we have an Android common kernel for LTSs 4.14, 4.9, 4.4, 3.18. And the Android kernel contains, so it's the LTS plus a bunch of patches that are necessary to run Android. Now that set of patches is a combination of technologies that we're working on and intending to bring upstream. So an example of that is EAS, where there's a fairly large patch set that we've been maintaining in common. But meanwhile, with the ARM team and with Linaro folks, we've been bringing that up into upstream Linux. And so that patch set is diminishing over time and will eventually disappear. There's a bunch of other patches which we really don't have any good excuse for why they're sitting in common and aren't merged upstream. So we also have accumulated some technical debt here. So we add our technical debt at the Android common level. And we're actually getting a bunch of help from some of the Linaro team on that as well, of taking some of our debt, merging it upstream, or in some cases we're re-implementing as user space features, and so that we don't have to carry it in common. So an Android kernel, to function properly, you need at least the stable plus the Android common, and then you have something you could run, say, on an emulator or something like that. And then if we're going to actually run it on hardware, we need some more. And so if we go down one level, we have what we call the SoC kernel. And so this would be, say, Qualcomm and their flagship silicon for that year. This is where they would add all the secret sauce to support that SoC. And then finally, the device kernel. So that could be, for example, where things that are specific to a specific device, so Pixel device, the device drivers for the touch panel and that sort of thing, are inserted at the device kernel. And what's new from the way we used to do things is that we are now in a regular cadence of merging down, where once a week or so, when Greg KH releases a new LTS version, so like 4.4.96, that version is merged down into Android Common. And we do a bunch of testing. And actually, one of the reasons we joined Linaro a few years ago was to take advantage of the expertise that exists in Linaro to help us out with the testing and some of these activities around getting the patches to flow down. So LKFT has been critical to being able to give our downstream partners, the SoC vendors, confidence to take the common kernel, merge it down, because it's been tested. The SoC, the Android Common is merged regularly down to the SoC kernels. That's done by the SoC vendors, and that's also done on a fairly regular cadence. And then eventually, on some devices, it's merged all the way down to the device, and you can actually see it. That's part that we haven't completely worked out yet, and are still working with vendors and OEMs. So another part of what the maintainers complain about, and this is a big part of why we don't run mainline, is that typically the kernels that ship have many lines of code. I think Greg did the accounting on it once and found that slightly more than half of a binary running on a device is generated from out of kernel code, out of tree code, which means it comes from, it's part of our technical debt, or it comes from the SoC vendor enablement of the silicon or from the device. And so he kind of refers to it at that point as Linux-ish, not truly Linux. And so obviously what they'd like to see is everything upstream, so that you can actually run the kernels using mainline kernels. Now there's a bunch of reasons that doesn't happen: business reasons, cultural reasons. Some of this hardware has pretty limited lifetimes, and the teams are busy. They get it done, and then they move on to the next project. And culturally, if you're not just working upstream, it's really hard to retrofit it upstream. And there's good reasons to work upstream, as we in this room know. And But there's also IP reasons and cultural reasons why it isn't happening yet. But we do see a few cases where the code is getting upstream, and notably right now we have the SDM845 code from Qualcomm is being merged upstream, and that could enable there to be some phone form factor devices that maintainers upstream will eventually be able to use. And I expect to get there is going to be with the help of a bunch of people in this room to help support that and test it and help get the full set of features and drivers upstream where it can be used with upstream code. So this is my so I think that's sort of the silver lining and the exception to the initial statement that all kernels are going to be at least 2 years old. I think we have some of these cases where at least we could have a few devices, and then maybe in the distant future we can get to where SoC development is being done upstream too. But that's a long road and a difficult one. Going back to this picture, one thing you'll notice is that the arrow for the LTS kernel ends very early. So that pretty recently we were in a world where by the time we get around to shipping a device, the kernel that it's based on has only a few months left of its support lifetime. And so when that support lifetime ends, then Greg stops taking the critical fixes and bringing them in, and that flow of patches downstream to the device gets cut off. And we recognized this was a big issue when we were changing to this new model, and this was another thing that was a motivator for us to get involved with Linaro, because we've gotten an enormous amount of help to make it possible to extend that LTS out to 6 years. And so Greg KH agreed to do a 6-year experimental LTS support for 4.4, and Ilian announced that at his keynote last year, and in general went really well. It was experimental though, and so it was kind of funny during this last year, we'd have a lot of SoC vendors coming to us and saying, well, okay, 4.4 has a 6-year lifetime, but 4.9 has only a 2-year lifetime. So it looks like I get a better support if I ship with 4.4 instead of 4.9, let alone 4.14. And so this is sort of getting us into, we have this sort of difficult dance right now where Greg doesn't want to sign up for supporting 6 years for everything until he sees that it's actually working and people are actually using it. And so he wants to see that when he picks up a 4.4 based device, that it's running a recent 4.4, not a really old 4.4. And he considered it enough of a success that he recently announced, okay, 4.9 is now a 6-year LTS. And if it's a success, he'll do the same with 4.14, and if it's enough of a success, that's just going to become the model. But until then, we're going to have, so right now we have people coming to us and saying, okay, I don't want to use 4.14, it's only got a 2-year support. I want to use 4.9 instead. And so if anyone is asking you that, tell them they should use the latest one that they can, and it's going to get a 6-year lifetime, assuming people are actually using these lifetimes, and if they're not using it, he's going to stop. So there was a while during the 6-year LTS where what we saw, where the patches were merging down to the SoC kernel level, but they were never going out the door on a device. And so this was a little worrisome. But things are getting a little bit better. So if we look at a recent device, this is our Pixel 2. It initially shipped on a 4.456 base, and each of the major releases that we've done, the MR1 and the Pi release, it got an update of the LTSs. So this is Greg's idea working. Not quite as well as he'd like, because you can see there's a 6-month lag there for the last one, which was because we had some internal issues, and so they froze it a little earlier than we thought that they were going to for Pixel. But when we have another release of Pi, so we're going to have these, we're not going to have any major releases or MRs, but we are going to have some maintenance, some I don't even remember what they're calling it, but periodically it is going to get updated at the kernel level. But This is Greg noting in the same article, vendors are coming around to using the LTS updates, but there's a new problem in the form of carriers. It isn't really a new problem, but it's a new problem to us because we never were doing this merge down before. A new problem in the form of carriers who are unwilling to ship those updates. So the carriers decide whether they're going to support your device on their network. So, the different carriers behave differently, but many of the carriers look at our monthly security bulletins, and they say, okay, for a security release where you're not going to go through full qualification, we'll let you ship those patches that are specifically cited in the security bulletin, but that's all, because more patches just means more bugs, and we don't want to take them. And so we're still in a world where, for the most part, the security patches that go out monthly are just including those few patches that are cited in the Android security bulletins, and therefore don't contain a bunch of fixes that are real. And in fact, just about a month ago, there was another exploit that was observed in the field. For Pixel, we got lucky because we had just updated the kernel. But for a bunch of other vendors who hadn't had that yet, they were hit with this. And if the security releases allowed us to actually ship the full LTS, then a bunch of these exploits would just not have happened. Because as I said, at the maintenance at the LTS level, they're getting a bunch of fixes. A lot of them are fixes for serious security problems, but they're not marked as security patches. You can't go look at the log and say, okay, there's a security patch and there's a security patch. You don't know until you get burned by not having it that it is. And so we have this goal, and we're working with carriers to let the security updates include all the LTSs since then, so that we can keep everybody up to date who's willing to do it. It also takes a lot of effort on the part of the vendor and the OEM, so it's not just us, but we're trying to sort of smooth the road so that anyone who wants to update with everything that's really needed can. We've been adding a lot of tests, and again, this is in collaboration with Linaro, adding a bunch of tests. We're testing, in LKFT, we're testing the upstream, the LTS releases, the Android releases. We're trying to test through the whole sequence, and the SoC vendors are also testing when they take Android releases. So there's a lot of testing going on. We're adding tests to ensure and give more confidence that nothing is breaking. But the Linux community makes a pretty good guarantee that they're not going to do anything that breaks ABI for user space, for applications, and so on. And we do have some carriers where they're getting close. I think we even have one case where they've kind of okayed, yeah, we could go for that. And so we're making progress here. Okay, so circling back to Project Treble, this is a slide that Ilian showed last year where prior to Android Oreo, we had this sort of messy relationship between HALs and extensions to ASP, and this made it very, very difficult to update when we get a new release. And he shows this beautiful picture on the lower right of how Oreo has cleaned all that up. And of course, it's easy to draw straight lines, and it's not always as neat as it seems. But a lot of things are a lot cleaner. So for example, one thing that has changed on the kernel side is if you look at how in Oreo and later, we have a kernel image, and that is on one partition, and we have kernel modules which are on a different partition. And the idea, and we're not doing this yet, but the idea is that we can eventually get to a world where the different owners of components can update their pieces separately, so that when a new dessert release comes out, the system partition can be updated. When there's kernel security issues, the kernel can be updated, but maybe with leaving the modules to be updated by the OEM if those need to be updated. We are not at that point yet. And in fact, there's some more separation that has to be done to get there. In particular, the vendor partition has like drivers, OEM modules, we envision eventually getting to, and this may take a really long time and a lot of work, getting to where we have kind of a generic kernel image and then SoC support as a separate thing, where kernel modules that are for supporting the SoC are in one place, updatable by that vendor, and then kernel modules for the board are somewhere else, updatable by that vendor. And so we want to get to a world where we've reduced the spaghettiness a little bit more and partitioned it into places where updates are much easier, much more complex to develop and to deploy and to test. But there are some other big issues that get in the way aside from just separating it, the hard work of separating it and the hard work of figuring out what is really the generic kernel image. I suspect we'll start out with kernel images that are per SoC family or something like that, because right now a lot of that SoC enablement happens directly in the core pieces of the kernel. So we need to work out exactly how we get there, and there's a long way to go, but there's also some fundamental issues before we can update things separately, not the least of which is the fact that the kernel doesn't really support any notion of in-kernel ABI stability. So if there's any update on a kernel, they make no guarantees. So this includes within an LTS. So this is an article that Greg Kjos wrote on the right. You can go read it, but basically the name of the URL, you can't read it there, but it's called Stable API Nonsense. And this is Greg Kjos writing about why there is no in-kernel stability. If you take an LTS merge, it's quite possible that your modules will all be incompatible now. Things can change. Now, of course, we've been talking to him, and even in the article, he points out that it could be managed under very narrow circumstances. Unfortunately, those narrow circumstances do apply to our case, where if it's the same architecture, same tool chain, same config, then it could be managed in a way to provide ABI stability for drivers. And if we're ever going to be able to update the kernel separately from the modules, we have to be able to guarantee this somehow. Because the kernel can be updated, the modules are still the old ones. If there's something that changes, some structure that changes, or an exported function that changes, then that could be a problem for that module. So one of the big areas that we're working on sort of going forward to prepare for this day that's a ways in the future is we're working with Greg on process things, and we're working on ABI tests to test whenever there's a LTS update, what things have changed or what things potentially have broken. So for example, here is the output of a test. This is just one part of that output, but it's showing when we went from 4494 to 4495, somebody changed the definition of the key struct key, and they added an element in the middle of it. And so the tool flagged this. Here's the structure that changed, and then it listed the 3,410 interfaces that would be broken in the ABI because of that change. And so what we're planning to sort of work out in this with Greg's help is that he'll run these tests when he's doing an update, and if it's an easy fix, if there's something he can fix very easily, in this case it might be fixable, we'd have to look at the details because it might not be, but it might be fixable by just moving that new structure element to the end. It might. I don't know for sure because I didn't look at this one. And if that's true, then he agreed that he would be willing to take in a fix for that at the LTS level. Another option then would be it flows into common, and we could fix some of these ABI issues at common. But there's also going to be some ABI issues that we can't fix. So for example, if we have another event like Meltdown or Spectre, there's no way that can be fixed without breaking things. And so we're always going to have some cases where it has to be a synchronous update of all the pieces of the kernel. So we're just resigned to that, but we're going to try to get to where most of the time we don't have to. Another approach that we're taking, and again, this is a pretty long-term approach, is right now there's over 30,000 exported interfaces. So if you write a module that's external to the kernel, you can only use the interfaces that have been exported. So you can't just call any function in the kernel. They have to have been explicitly exported. But there's a whole bunch of them that have been exported, but they're really not for general use. They're really for maybe two modules who depend on each other, or very specific uses within a subsystem. But right now there's no namespace control, so anybody with a module can basically call any of the exported functions, and often they do. And so we're trying to help the kernel community get a handle on that, and we submitted a patch that's actually gotten pretty good feedback so far, which introduces a notion of namespaces for exported functions, so that you could, for example, within the USB framework, tag it as USB exported. And then in the module, you would say import USB, and you can declare which functions you're actually depending on. And this would allow us in Android to basically disallow modules through VTS testing and so on that are depending on kernel things they shouldn't depend on, and reduce the number of potential ABI breakages by reducing the namespace of modules they're using. So this is a very long-term thing. This is something we're working with the kernel community with. It's going to be a topic at Linux Plumbers next month. But this is sort of part of our plan to sort of straighten out some of these kernel problems. So for our team, the things that we're focused on, first of all, we've changed our way of managing the Android common kernel. We used to be pretty permissive on people submitting patches and just adding functionality. And that has led to what I described earlier as our technical debt. We've got just a bunch of patches that we have to support now because they're there and people rely on them, but maybe they're not appropriate to go upstream. And so we're working on that. We're also working on that technical debt by dropping the patches that really we don't need anymore, by re-implementing some of them in ways that can either be sent upstream or can be re-implemented in Android user space. As I mentioned earlier, we're working with vendors on accepting LTS as part of security patches so that we can keep everything up to date and more solid with regards to potential security exploits. And we're improving our tests kind of all around, improving our tests just for acceptance of LTSs and making sure that the kernels are solid. But then we're also working towards that time where we can do separate updates. So we're doing lots of ABI tests, and then we're sort of at the very beginning talking to SoC vendors about this generic kernel interface concept and how we can. So that's sort of a long-term thing that we'll probably be reporting on in a few years. So that's it.
Todd, thank you so much for coming here. Maybe we could take just one or two quick questions. Anybody have a question? That was all straightforward for everyone? All right, okay. Mr. Gallo?
How can the operators be in the middle between the upgrades that my phone can download from the Google Play Store? That was
why do we care
yes.
about carriers?
Yes.
Is that the question?
Yes.
Well, in the US, it may not be true everywhere, but in the US, they exert a lot of control over who can be on their networks. And in particular, many of the device sales, most of the Pixel sales are through Verizon. Most of device sales in general, Samsung and Apple, are through the carriers. And so it's true that if you have your own device and you want to put your own kernels, my device has my own kernel on it, so in that sense, they can't enforce it. They don't shut me down because I don't have it. But since they're in control of the devices, they basically say, okay, I can't sell these devices. I'm not approving this device unless, and they exert their control that way. So where it's the main sales channel, the main conduit between the provider and the customer, they can say, this needs more qualification. This needs to go through a full certification, which is a big, lengthy process that we can't do for monthly security patches. We could consider for kind of a quarterly release, but not monthly.
Todd, thank you so much. Really interesting stuff.
You bet.
Okay, so Demo Fridays at noon. It's on the second floor where lunch gets served. It's only a couple of hours from now. We're really happy that everyone's here this week. We hope you had a really good week this week. We'll close it out at the end of Demo Friday. We'll see you down there at noon. Oh, one more footnote about AutoWare. So AutoWare is a new project in Linaro, and we're looking for member participation. So if Kato-san's presentation looked interesting, please come and talk to someone from Linaro if you think you'd be interested in participating. Because we want to make sure AutoWare as an open source project runs really well on ARM. And there's some work to